So in chapter 3, we want to look at functions. Okay. So in programming, a function is just a named sequence of statements that perform some kind of computation. So when you define a function, you specify the name and then a sequence of statements that's going to perform that computation. Later on, you call that function by whatever name you defined. And then functions can have arguments. These are values that you have to give to the function that it needs in order to be able to perform its computation. And then oftentimes functions can return a result that's called the return value. So these are just our definitions of terms. Now, we've actually already seen several examples of functions and function calls. Okay, so for instance, we went into the interpreter and we typed, type 7. Okay, so type, this is a built-in function. Okay, and the name of the function, so it has a name and it's called type. And then this right here is the argument. Okay. And so we would say type 7, and then if we were to actually go do this, let's actually go ahead and do this. Let me find. So if I had typed type, and then I put 7 in there, notice the value associated with that is class int. Okay, so that is actually the return value. It's the return value of this function. So the return value is class int. So it's telling us that it's an integer. Okay, so that is an example. So I just made a function call by saying the name and then in parentheses giving the arguments that it's expecting. And then it does whatever it needs to do. I don't know what it does, but somewhere wherever the function is defined, there's a list of statements that helps it figure out what the type of the number 7 is. And then once it figures that out, then it returns that. Okay, this is supposed to say return. So the return value is that it's an integer. Now, of course, again, this is the name of the function, and we have a different argument. If we send the argument, okay, in single quotes, hi there, so if this is argument, then the return value will be string, right? It'll tell us that it's a string. And if we were to do this with 3.14 being the argument, the return value would be float. It would tell us that it's a floating point number. Okay, so those are the different return values and we've already seen how that function works. So the way that you call a function is you just put the name and then in parentheses whatever the list of arguments that it's expecting. Okay, we've seen things like that. We saw type. We've seen some math functions, which that's a little bit more of a familiar idea about a function because you've done math functions in math a lot. So, sine, cosine, square root, all of those are function, and we send in something like what the sine 90 or math.cosine of math.pi, etc. So just to review, let's go ahead and try those ones. So let's just recall that if I just do math.sine 90, I'm going to get an error. It doesn't know what math is. The only way I can, because that's actually in a module. So the only way for me to get access to things in the math module is to say import math. Okay. Now, if I say math.sine 90, it'll give me an answer. Now, if you think about it, and you think of the sine of 90, you're probably, if you're not thinking real carefully about it, you should be thinking, you're probably thinking, oh, well, the sine of 90 is 1. Why is it 0.893996, etc.? Okay, so remember that by default, Python will do sine, cosine, tangent, all its trig functions in radians, not in degrees. So if you're used to using degrees, just be like that 90, that should be pi over 2. So if you want to do, if you want the sine of 90, you're really going to have to do math dot sine, and you need math dot pi over 2. And that will give you the one that you're expecting. So that's a good reminder that Python uses radians. Okay, so this is our function name, and this is our argument. The return value is what? It was 0.89 something. 0.89 blah blah blah. I don't remember. Okay, and then if we did math dot cosine of math dot pi, this math dot pi is our argument. Okay, and then we probably expect that to be -1. Let's go ahead and check that. Make sure that it works the way we expect. So if we did math dot cosine of math dot pi, oops, sorry, math dot cosine of math dot pi. Got to type it right. We get our -1. So notice the return value, as expected, is -1.0. We'll return a floating point value, not an integer. So even though you're probably just thinking -1, it will do -1.0 because it is a floating point value. And math.sqrt, that's the square root function. Okay, and with an argument of 25, you are probably expecting the value 5. Let's check that one, math.sqrt of 25. Okay, and once again we get a floating point value, so the return value is 5.0, floating point. Notice that is the principal square root, so this will return the principal square root. So if you want the -1, you would have to do negative math.square root of 25, or -1 times it. Okay, so we've seen those types of functions, and then we've also seen the print function. And the print function actually doesn't return anything. So notice here where I put functions can return a result. Maybe you should put a little note here. Okay, they don't have to. So they don't have to return a result. So we've seen examples of functions that don't return results, like the print function. Okay, and so if I say print hi there, okay, so you might feel like, oh, it's printed, maybe it returns something, it returns hi there. That's not a return value, actually. That's just the execution of the statement. So for example, let's say I want to say, value, I say equals print hi there. Okay, so it prints hi there, but if I look at the type, it's like, what did print actually return? So if I look at the type of value, it tells me there is no type, none, there is nothing there. That's different than if I did answer equals math dot square root of 25. Okay, and so when I do type of answer, it'll tell me it's a float. It's returning a floating point value. Whereas that print statement, it didn't return anything. It returned nothing. So I tried to hold on to whatever got returned by print, but there's nothing there. It didn't return anything. It did something. It printed hi there, but it doesn't return anything. Okay, so hopefully you can kind of get the distinction between those. So just because it does something doesn't mean it returns something. It actually has to produce a value with a type for it to return something. Okay, so one thing to notice is that the print function is interesting. Back here, like I always passed in one argument, one argument, one argument. Some functions, notice this has one argument. So the print function can just, you can pass it one argument, a string. Okay. Oops, my window's in the way. Sorry about that. Okay. This one has, you know, about print, the answer is, comma, answer. So that comma is a separator between two different arguments. So there are actually two arguments in this one. So all the arguments would be separated by commas. And in this one, you can just do print and then pass it 0 arguments. So the function doesn't have to have arguments. Okay. This would just print nothing. It would just a blank line, basically, just nothing on it. Okay, so a couple of interesting things that we see here is that there can be the arguments are separated by commas. You can have more than one argument to a function, and then some functions can have an arbitrary number of arguments. We probably are not going to get into how to write functions with arbitrary number of arguments this semester, but it is just interesting to know that you can do that. So when you get into a little bit more advanced programming techniques, you'll be able to figure out how to write programs that have, you know, a different number of arguments. It doesn't always have to have the same number of arguments. But the functions that we will write this semester will always have the same number of arguments. So, okay, we're going to look at some built-in functions first, and then we're going to write some of our own functions. So we've already, like I said, you've seen in functions in the math library, you've seen the print function, but we're going to look at some other functions that come in handy that are built in. So Python provides built-in functions that convert values from one type to another. So the three functions are int, float, and str. And you can probably, if I say that they convert values from one type to another, you might even be able to guess by the name of the function what they do. And that's a good thing to note, is that when you write your own functions, the way that you name it, you know, somebody should be able to guess what it does by looking at the name. So you always choose good names for functions. That's what Python, the built-in functions, they try to choose good names as well, so that you don't have to, it's not so hard to remember what they do. If you just call them like X, Y, Z, K, Q, like nobody's going to remember what they do. But if you call them things like int, well, that takes a numeric or string value and converts it into an integer, which makes sense. That's why you call it int. The built-in type conversion function float takes a value and converts it into, you guessed it, a floating point number. str converts something into a string. Okay, so let's look at how this works. Let me move this over so we can see our examples. Okay, so for example, if I type int and then 2, 4, that's going to take the string containing the characters 2 and 4, and then if it can, it's going to convert that into an integer. Okay, it can. So that returns the value 24. So let's write this here. Let's make a little table of what it returns. So this one returns the number 24. Okay, let's try this one. If I do int, and then I pass it the word 2, okay, and that just gives me an error message. Okay, so the only kinds of things that it can convert are just a string that contains digit characters. So you have to have digits in there. So it doesn't know like 220. You can't pass it a word out the spelling. It has to be actual digits. Okay, so this will give us an error. Okay, let's see what int of 3.14 does. Maybe you should make a guess of what you think it might do. So if I do int 3.14, it returns 3. Okay, now the reason that it returns 3, okay, you might think, oh, it's just rounding it. So that's a good hypothesis. Maybe it's rounding it, but if that's what you think, you should probably try other things as well and see if it really is rounding it. So let's say we did int and then 2.71828. Okay, so if it's rounding it, then this should also return 3, just like the previous one, because 2.71828 rounds to 3. It doesn't return 3. Okay, it returns 2. This one returns 2. Okay, so it is not rounding. Okay, it is not rounding. All right, so maybe you're thinking, all right, well, it's not rounding. Maybe it's taking the floor. Because notice it just like chopped off the decimal part here, and it chopped off the decimal part here. So maybe it's going down to, and it's doing the floor and getting rid of all the decimal parts. Okay, so that's a good guess. So let's guess that. And if it's rounding, if it's doing rounding down to the next integer, if you think about negative 3.99, okay, the integer that's less than or equal to that would be negative 4. Okay, because if we would need something less than it. Okay, so let's try that one. Int negative 3.99. And that's just giving us negative 3, not negative 4. So it's not doing the floor either. Okay, so it's not rounding, and it's not doing the floor. It's doing a truncate. Okay, so it's just chopping off the decimal part. Okay, so okay, this is a truncate. So in other words, it just removes the decimal portion. Just chops that off, and it just gives you whatever is in the integer part of it. Okay, whatever is in front of the decimal point. Anything after the decimal point gets left off, it was thrown away. Okay. So that's the trickiest one. The float and string, there's nothing, you know, there's nothing too tricky about that because integers are subsets of floating point numbers, and so it just adds extra stuff, and it doesn't, you don't have to worry about trying to take something away. Okay, so let's look at what float 24 does. So if I type float and then pass it an integer 24, it gives me 24.0 as expected. So this will give me 24.0. It just turns it into the equivalent floating point number. Okay, and if I do float, and then what did I have here? 2.71828. So if I pass it a string, as long as that string has a bunch of characters in it, it can convert it. A bunch of digits in it and a potential decimal point, it can convert it. But just like the int one, it can't do words. It has to have just digits and potentially one decimal point in there. So this will turn it into 2.71828. Okay, okay. So it can't do non-numeric characters. So it can't be a word like 2.7, you can't spell it out or something. So no non-numeric characters, just like the int one. Okay, and then str, let's try that one. So if we do str and then 24 in parentheses, okay, notice it returns to us a string containing the characters 2 and 4. So this will return the string containing the characters. So notice that these are characters, not integers. Okay, and similarly, if I did my str with a string that contained the characters 2.71, sorry, and I pass it the floating point number 2.71828, I'm telling you what the answer is. So if I did a string and I pass it a floating point number, it will give me the string that contains the digits that represent that floating point number. So it'll give me a string with 2.71828. Okay. Okay, so each of these, notice they just take one argument, and then this returns a string, float returns a float, int returns an int. Okay. And then the other built-in functions are from the, you can sometimes find them in modules. So they're not part of the language itself, but they are part of a standard library that you have access to. All right, so a module, sometimes you'll hear people call them a library. It's a file, and it contains a collection of related functions. So the math module contains all of the things that do math. Those are all related, so they put them all together in one library or one module called math. There are other libraries that do other things, and they always put things that are grouped similarly together so that you know where to find them. Okay, and so the math library or math module gives you most of the familiar mathematical functions, and maybe even some more that you're not so familiar with. But now, we've seen this before. In order to get access to the math module, you have to use the import math statement. Okay. And so I've already done that here, but let me go back. Remember, we tried to do sign back here, and it didn't work until we typed in import math. Okay. So we've already kind of seen that, and then in order to get access to the math functions that are in the math module, you always have to put math, the module name that it comes from, and then dot, and then the function name. So notice that here, this is the module name. And then these here, these are the function names. Okay. So we've looked at examples. So that module contains both functions and variables. Okay, function or variable. Because pi and e, those are variables, but sine, log, and log10, those are functions. Okay, so that dot notation, this dot notation where you use the module name, dot, and then something from the module, either a variable name or a function name, whatever you want, to whatever thing you're trying to access from that module. So that's that dot notation that has to be used. One thing that we've already looked at, sine, and kind of pointed out the fact that sine automatically does radians. Another thing that we should probably point out is that if I do math.log10, okay, now if you went onto your calculator has, you know, like an LOG button and an LN button. And if you did LOG, that automatically means like log base 10, right? And if you did LN, that means log base E. Different in Python, so be a little bit careful about this. So if I just do math.log, I'm like in my mind where I've used the calculator, I think it's log base 10. So if I do math.log of 10, I should get 1, right? Oh, I don't. I get 2.302. So what's going on there? Well, that's not log base 10. That is log base E. So if I do math.log of math.e, that will give me the one that I'm expecting. So notice that the base of just plain old log is, so this one is log base e. And this is the natural logarithm. Okay, if you want log base 10, then you have to say log 10. This is log base 10. Okay, so it's just something to be aware of if you have to use logs in any of your programs, that it is different than what you are used to on your calculator, and there is no ln. And so if I were to try, if I did like math.ln of math, well, let me just do some number like 100. Okay, there is no ln in the math library. Okay, so just something to keep track of, since I know that's going to be slightly different notation than like your calculator. Okay. Here is a list, a partial list. It's not a complete list, but I picked out the ones that I thought would be perhaps the most commonly used by students in this class. So there's a math.ceil. Okay, that's the ceiling function. There's a math.comb n comma k. If you were to guess what that is, you'd probably guess that that's combinations of n things taking k at a time. So this is for doing combinations. There's math.f_abs. Okay, this is basically the f stands for floating point, absolute value. Okay, so let me just pop this up here. So if I did math.f_abs, and then I did like -3, notice it returns to me 3.0. Okay, so it is the absolute value, but it's also going to give you, always going to give you a floating point. That's why they put the F in front of it, to help you remember it's a floating point absolute value. So even though I gave it an integer of -3, it returned to me the floating point absolute value of the argument. Okay, factorial, pretty self-explanatory, I think. It just does factorial. So notice we don't have a nice exclamation point. You actually have to write out the whole word factorial to get the factorial. Floor takes the floor. GCD, you can actually put a list of integers and it'll tell you the greatest common divisor of the integers. So if I did math.gcd and I pass in, let's see, let's do 6, 30, and 12, and sure, that's good. And it'll tell me what the greatest common divisor is. Let's say I did math.lcm, same numbers, 6, 30, and 12. It will give me the least common multiple of 6, 30, and 12. Okay, so those are fairly self-explanatory. So you have to have at least 2. You know, you can't have the greatest common divisor of one number. You have to have at least 2, but you can do 2 or more numbers for both greatest common divisor and least common multiple. Permutations is permutations of n things taken k at a time. I just cut these straight off the documentation page. If the second parameter, or the second argument there is you don't have to have it. You can only give 1 or 2. So if you don't give a second parameter or a second argument, it will just put nothing there. The EXP is the exponential, so it's sort of like the inverse of your natural logarithm. It's e to the x kind of thing. So let's try that one out. If I did math.exp1, okay, I should get an approximation of e. So that's e raised to the first power. So 2.718281828, and so on and so it goes. Okay, so that is e. Think of this as being e to the x. Okay. And then log, we've already talked about this, log, and then if you just pass it one value, you're going to get log base E, but it also does provide you an option of putting a second argument in there. So if you put a comma and then a base, so I can do also, if I want a different base other than E, I can actually use this. I can do math.log, and I can do the log of 8 base 2, and it'll give me 3 because 2 to the third is 8, right? Log base 8 of 2 is 3. So if I want some other base besides E, and so also almost says that, you know, log base 10, you're almost thinking you don't need it because I could do math.log, and I could do 100 comma of 10, and that would give me log base 100 of 10. So I can get a log base 10. The documentation will tell you though that log, this one is, that with the log 10 is a more accurate result for base 10 than if you put the 10 up here. So if you need a log base 10, use log 10 rather than the log with the 10 as the base. POW, this one is just like x to the y. Now again, you might, so this is, if you just are using like 2 to the third, you're probably just going to use 2 star star 3. But for floating point numbers or whatever, you might want to use the POW function instead. Square root, pretty self-explanatory. There's a COS and COS. So this is the inverse cosine. The A is for arc. So this is arc cosine and cosine, arc sine and sine, arc tangent and tangent. Okay, so all of the trig functions and inverse trig functions, notice there aren't functions for cosecant and secant, and you would have to do, just like there aren't any of those in your calculator either. So if you ever needed those, you just have to manually do those with reciprocals and such. Okay, degrees and radians, those are the last two that I thought would be useful. So here, degrees, okay, we'll take a radian argument and convert it to degrees. And radians will take an argument in degrees and convert it into radians. Okay, so if I did, let's go ahead and try some of these. So let's try radians first. So if I did math.radians and I put 90 in there, okay, that's going to tell me how many radians 90 degrees is. Now you probably think of it as pi over 2, but let's look at what math.pi divided by 2 is. It's that value, right? So it's not gonna tell you like pi over 2. It's gonna give you an approximation for pi divided by 2. Okay, and then for degrees, so if we did math.degrees, and let's type in this 1.570796. Let's do that. And we should get something very close to 90, right? Yes, very close to 90. Okay, so that just converts between radians and degrees, so that's helpful if you have something in degrees and you don't want to have to manually convert it, and you can just get call the math library functions to convert it for you. Okay, so that's a quick intro to functions. We'll look at some more in the next video, but those are most of the useful functions that we've kind of seen before and are a little bit familiar with. And next time we'll get into things that we're not so familiar with.